Hi, everyone. I'm Andrew.
And I'm Daniel.
We're both engineers at Monzo, as Sahil said, and we're here to talk about how Monzo tolerates full cloud outages. In the last 2 years, 9 major banks in the UK suffered from a total of 803 hours of downtime caused by IT failures. This isn't because they don't care about reliability. A lot of time and money is spent at these banks making sure their systems are reliable, but yet outages still occur. Monzo's a bank. We have 12 million customers in the UK, and we add millions more every year. If our systems went down, we'd cause a very large impact to our customers. They might not be able to spend their money, buy their food, pay their bills, or even get home. So reliability is really, really important to us. But how do we achieve it?
So it's got to start with getting the basics of cloud platform resiliency right. So what are the basics? Well, back in the old days, it was normal to run all of your systems on a single mainframe computer. And for a little while, reliability was all about making that one mainframe more reliable with things like RAID storage and error-correcting memory. But at the end of the day, it was just a single server, and if it did go down, you'd have an outage. Google was one of the pioneers of moving to a distributed computing model where server failure was something that was expected and should be dealt with automatically. Beyond replicating across servers, we then moved to distributing those into different availability zones, giving us resilience to an entire data center going down. So the basics get you quite far. We've solved for the failure of an individual server. We've solved for the failure of an entire availability zone or data center. So that gets us quite far. Are we done? Does that give us a perfectly reliable system? No. We're still susceptible to outages of an entire cloud region or a whole cloud provider, which up until last week I would have said was quite rare, but Google's trying to change the probability of that a little bit. But there's also another class of failure, which is software failure. So if you're running the same software multiple times, if the bug is in the software, then just running it more times doesn't really help you with that. And in practice, that second category is significantly more likely than the first category and drives a lot of outages that we see.
One way we could try and solve this is using fully active multi-cloud platforms, but we don't believe they work in practice. If we go back to the diagram we had before, the next real logical step forward is to change your multiple availability zones for multiple cloud platforms. To maintain quorum, when we use multiple cloud platforms, we need to use at least 3, not just 2. And therefore, theoretically, we think this setup still could work, but it doesn't really offer practical results. The reason being, every database operation, every message emitted on a queue needs to be coordinated across those 3 at least clouds. That increases latency to our customer product, which means that our customers just get a much slower, much more janky product at the end of the day. That might be fine for some applications and some products, but for Monzo, we operate at a scale where we have multiple millions of database operations a second, so this really wouldn't work well for us. So yeah, we believe that active multi-cloud platforms just wouldn't work. If we go back to the diagram we had before with the 2 failure modes, fully active multi-cloud only really works for that first bucket. If we're running across different cloud platforms and it's the same software deployed to each, then the software failure will obviously take all of them down together. So even fully active multi-cloud platforms, we're still prone to that software failing.
So traditional disaster recovery does a good job of mitigating the risk of servers and data centers going down, but in modern systems, the risk of outage is typically dominated by bugs in the software itself, and it doesn't do a great job of dealing with those sorts of failures. So a good case study to illustrate this is the outage that affected the National Air Traffic Service in the UK in August 2023. The outage was 3 hours long, but the knock-on impact of that outage lasted 3 days, impacted over 700,000 passengers, and has a total estimated cost of £100 million to the industry. So what went wrong there? Well, there was a critical exception that occurred when the primary system tried to process a particular flight plan and was unable to generate a valid route for that flight. The secondary system kicked in within 20 seconds and took over from that primary system, but because the secondary system runs an identical copy of the software, it reached the same fate, it got to the same critical exception, and also crashed. So when we're thinking about how we make Monzo the most reliable bank that we can, we want to think not just about failure of servers and data centers, but also acknowledging that we're all humans writing software, and that software will contain bugs. And we want to build a system that can still provide our customers with a good service, even if our software has bugs.
So we built a system that we call Monzo Stand-in, get a bit of feedback, with different software, data, and infrastructure. This isn't a substitute for all the resiliency basics that we talked about. We still have our primary platform, and we really focus on reliability there, using replication across multiple availability zones in a single region. Monzo Stand-in is all about acknowledging that even with that, sometimes things still go wrong. And this gives us an extra layer of defense. By design, the Stand-in platform only serves our most important services to our customers. We really took the time to think about what really do Monzo customers need and what do they depend on 24/7. For us, that's things like making card payments, withdrawing cash, sending bank transfers, seeing your balance is fine and freezing your card. Really, it's like the paying bills, paying for your shopping, and making sure your money is safe. They're the most important things. Stand-in runs in a different cloud provider to our primary platform. Our primary platform runs in AWS. Our Stand-in platform is in GCP. And we minimize the code that we share between those two platforms. The reason we do that is to minimize the risk that software bugs in one impact the other. We don't believe we can ever achieve fully exact independence, but we aim to maximize the independence of the two platforms as much as possible. So what does this look like? Roughly, on the left, we can see that our primary platform, we have over 3,000 separate microservices, like I say, running in AWS. On top of those components, we have platform components like databases, queuing, secrets, etc. We use Cassandra-like database and Kafka for events in our primary platform. In our Stand-in platform on the right-hand side, we have just 18 services. This is running in Google Cloud, and we use cloud products like Datastore and PubSub instead of those Cassandra-like and Kafka technologies. Those 18 services aren't a subset of those 3,000 in our primary platform. We've built these 18 services and the platform from the ground up. They're built specifically to be very, very simple and cover what's the most important things to our customers. When we use the Stand-in platform, we can configure it to enable different parts. One of those parts is our Stand-in app, which changes the customer's experience of Monzo. On the left, you can see the experience of our usual Monzo app. This is what customers see when they open their app usually. And when we enable Stand-in, you can see the experience on the right. It's much simpler, much more functional UI with a much smaller set of features. There are some small glimmers of delight, but we try and keep the system really, really functional.
So how does Stand-in work? So we've got these two platforms. How do they stay in sync? So it starts with syncing data from the primary platform to the Stand-in platform. So the Stand-in data syncer is a system that we built that listens for events from lots of systems across Monzo, things like accounts being opened, accounts being closed, transactions being created, balances being updated, etc. And when those events occur, it makes writes to the Stand-in platform to sync that data across. It's not syncing all of the data. It's only syncing the minimum data that that basic system in the Stand-in platform needs to do its job. So to give a sense of scale, the volume of writes in our Stand-in platform is 2,000 times lower than our primary platform. It's really focusing on that core data.
And if you're enjoying this, LeadDev has a ton more to offer.
I'm quite fond of the articles.
I feel like LeadDev blogs are my favorite, and it's been really, really useful to kind of create these more meaningful connections as well.
If there's something you're struggling with as an engineering leader, there's a pretty good chance that LeadDev has published something that addresses it.
So make sure you check out leaddev.com.
So how are payments processed in Monzo Stand-in? So if we've just enabled our Stand-in processing, and we have a customer that has £150 in their account, so we've synced across that balance into our Stand-in platform. We then calculate their total balance. So that has to subtract any payments that they've already made within Stand-in. Now, we've only just activated Stand-in, so the customer hasn't made any payments within Stand-in yet, so their total balance is still just that £150. If the customer then tries to spend £100, we'll see if they have enough balance for that. In this case that they do, that transaction will go through and we'll store a Stand-in transaction to represent that £100 that they've just spent. But crucially, the synced balance doesn't change. All of the data we sync into Stand-in is immutable, and whenever something is changed within Stand-in, that's stored as a separate sort of delta or change record, and this is what enables us to sync that data back into our primary platform in a way that avoids any sort of conflicts that can't easily be resolved. So what happens if that customer tries to spend another £100? Well, this time, because they've already spent £100, when we calculate their total balance, we subtract that £100 and get £50, and then when we compare that to the £100 that they're trying to spend, that will get declined because they no longer have enough money in their account. So when the primary system is back, how do we sync that data back into the primary system to make everything consistent again? So with that £100 that this customer has spent, that goes on a queue that we call an advice queue. That's not just for transactions, that's for any change that's made within the Stand-in system, be that a customer freezing their card, or perhaps they've inadvertently blocked their PIN. Any sort of state change within the Stand-in system is represented as an advice. We call it an advice because the Stand-in system is advising the primary system of things that have occurred within Stand-in. It's not kind of asking the primary system, could you do this? It's telling it, this thing has happened, please make the primary system consistent with that fact. So in this £100 transaction example, that will go into the primary platform, into our MasterCard card processor, which will then update the ledger to debit the customer for that £100 and create a new transaction record so that they can see in their app.
So to make sure that all that stuff works, we run a lot of testing in our Stand-in platform. If we'd built a traditional disaster recovery site, we'd maybe test this maybe once or twice a year, failing over to our disaster recovery site and holding our breath that it still works. Instead, we test the Stand-in platform all the time, in real time, with real customers, with real payments in production. One of those testing mechanisms that we use is one we call shadow testing, where we replay all the payment messages from our primary platform into the Stand-in platform to make its processing decisions about those payments. Once we have the two decisions from the two platforms, we can compare the results. We don't expect 100% agreement in all cases. We try and minimize the divergence between the two, and we can monitor where they diverge and how they diverge and by how much, and we can alert on that, but we don't expect the two systems to match exactly. Another mechanism we use is to test with customers directly in production. We enroll a sample of customers in Monzo Stand-in every day. These customers get the full Stand-in experience. All their payments are processed in the Stand-in platform. They see the Stand-in app UI if they were to open their app. And this helps us really, really test the behavior of the customers. We can see what works, what doesn't work. We can get the feedback from the app, from the back-end platform, and from our payments schemes themselves as well. Customers can easily opt out if they choose to as well by just choosing the option in the app. And finally, one other testing mechanism I'll go into is connectivity testing. So our main mechanism of connecting the Stand-in platform to payment networks is to route requests via the primary platform. This allows us to very, very quickly and very easily route traffic between the two. It helps us to segment customers between the two platforms when we test. But in the scenario where the primary platform is completely unavailable, we need to be able to make sure that the Stand-in platform can connect to MasterCard network, for example. Every day, we automatically establish connections from the Stand-in platform, which receives a burst of messages from, in this case, MasterCard. And that burst of messages will be unfiltered for all customers that just happen to be making payments at that time. This helps us test also the full sync back to the primary platform, so we're creating decisions, we're making payments, people's balances are updating, and the whole sync flow goes round the houses as well, so we get to test all of that. To accomplish all of this stuff, we had to make some really, really difficult trade-offs. We focused on delivering the most important things to meet our success criteria, one of which is we had to be comfortable with testing with customers in production. Our exec team and risk owners were initially very uncomfortable with the idea of testing with real customers in prod, but we demonstrated that it's really the only way to be fully confident that our disaster recovery system works all the time. Shadow testing, load testing, connectivity testing only go so far. Testing with customers in production with the app is the way to test that this thing works. Incident leads also need to have high confidence, ability, and authority to enable the stand-in platform. To be able to do that, we've kind of they depend on the testing that we've done, the testing results, and all of the coherence checking that we have with the shadow testing gives engineers that confidence, and that confidence is the thing that allows our exec team to be comfortable that engineers have the authority to change it without checking in with them. And finally, we had a very small empowered team to go and build this thing. We built this whole system with testing and launched it to customers in about 10 months with a team of 6 people. And we were able to do that by initially working with stakeholders in workshops, taking those stakeholders out and focusing the team on delivering. That meant that we didn't introduce any scope creep along the way. Some features also didn't make the final cut. For example, in our primary platform, we have a product feature called Gambling Block. In prod, this lets customers remove the ability to gamble. Initially, we decided to decline all payments to gambling merchants for all customers. This meant that we could trade off building the gambling block in the stand-in platform while still protecting customers. Since we've launched, we've gone back and revisited that. Our customer experience is much more functional, as we talked about before. This helps us to reduce risk, but it also helped us build a stand-in experience very, very quickly. And further, some niche products just aren't supported. So under 16s, business members rather than business admins, some of those product users initially weren't supported. Over time, we're adding support to our stand-in platform for those.
So we're really happy with the investment that we've made in Monzo Stand-in. It's given us a really powerful extra layer of defense, not a substitute for making the primary platform as reliable as we can, but acknowledging that even with all of that investment in the primary platform, some things can still go wrong, and this gives us another fallback to continue to provide a basic level of service to our customers. We're often asked, doesn't this cost a fortune to run? As Andrew said, it was just a team of 6 engineers for approximately 10 months to build the entire system for a whole bank. And the running costs of this system are about 1% of our cloud platform spend, so it doesn't cost that much to run.
Another question we get asked is whether it's a nightmare to maintain. And the simple answer is really honestly no. In the last 12 months, we've shipped to our primary production environment over 50,000 times. We ship changes in that same time to stand-in platform only a few dozen times. In the background, every week, we also automatically mass deploy those 18 services just to make sure they're the latest build, so this system doesn't deteriorate over time without change, but changes that system only a few dozen times.
So is it worth it? Will the system ever get used? We've used the system actually a number of times since it was introduced. Most notably, we had a 2-hour critical outage due to a platform migration that we were performing. By activating Stand-in, the impact of that incident was significantly reduced for our customers. They could continue to spend on their card, make bank transfers. The other sort of benefit of having this system is it makes large-scale technical migrations, such as changing an entire database, much easier and safer. Even with all of the preparation, those sorts of technical migrations are still scary and come with some risk. This, in turn, helps avoid a situation where sort of the fear of the risk of those technical migrations means they never get done and the system slowly decays over time.
And we believe there are lessons to learn from our system, but the system might not exactly be the best fit for your business. A platform like Monzo Stand-in is most applicable if you have full control over both the server and the client side of your application. Slack is a fantastic example of this. Today, if Slack went down, the whole system is down. You can't send messages, you can't do anything, but they have loads and loads of features that aren't critical to their business. If you take out emoji reactions, you take out huddles, you take out threads, you take out sign-up, you take out login, the thing that's most important is sending and receiving messages. A stand-in platform for Slack could simply solve that problem while they solve whatever the outage is in their primary platform. It's also most practical if a 2-hour outage is completely intolerable. At Monzo, we simply can't tolerate 2 hours of downtime. Customers in that time would need to spend their money, need to pay their bills, need to get home. So this really fits us well. It's also, we believe, much more cost-effective to run at a fairly large scale. There's so much more to Stand-in that we could have gone into today, but we don't have time. We will be around a conference if you want to come find us to ask questions. But that's us. Thank you so much.